Unit 2, Lesson 3, Analyzing Rational Number by Using Models. Part number 2. Belongs of an element to a set. What does that mean? When you want to say that negative 3 belongs to integer. Okay, I know that negative 3 is element of integer, so I said that negative 3 belongs to set of integer, but negative 3 does not belong to set of natural number, because natural number start with 0, 1, 2, 3, and negative 3 not belong to set. So belong and does not belong is relation between element and set. Element and set. Example number 4. Write belongs or does not belong. A. Negative 3 over 7 space blank to set of integer. I know that integer is positive and negative and 0, but no fraction. This is a fraction and also is negative fraction, so does not belong to set of integer. 0 blank to set of natural number. Natural number start with 0, 1, 2, 3 and so on, so 0 belongs to set of natural number. Okay, negative 4 set of counting number. Counting number start with 1, 2, 3, 4 and so on, so negative 4 doesn't belong to set of counting number. 0 blank to set of rational number. Of course 0 belongs to set of rational number. Okay, inclusion and subsets. When you want to say that set of count and set of natural, set of integer, set of rational number. Again, the smallest set is counting number, set of natural number, set of integer and set of rational number. I want to say that counting number is a part of natural number, so set of counting number is a subset of natural number. Also set of natural number is a subset of integer. Set of integer is a subset of irrational number. Okay, take example number 5. Write subset or not subset. Set of integer is blank of set of counting number. Is integer is part of counting number? Is integer part of counting number? No, counting number is part of integer, so here we write not a subset. Set of natural number and set of integer. Of course, set of natural is a part of set of integer, so I said that set of natural number is a subset of integer. Set of counting and set of rational number. Counting is a subset of rational number. Rational number and natural number. Is rational number part of natural? Of course not. So we said that set of rational number is not a subset of set of natural number. So tab subset and not subset. Relation between two sets. relation between two sets like counting set and natural set and integer and rational set. Okay, but before we want to belong and doesn't belong. Between element and set. Relation between element and set, use belong or doesn't belong. But relation between two sets, use subset or not a subset. Okay, subset and not a subset between two sets, but belong and doesn't belong between element and a set. Check your understanding. Number 1, write the given rational number in a form of a over b. Here we have 4.5. 4.5 is a mixed number, right? Okay, I need to convert this mixed number to this picture of a fraction. We said before that we have 2 in the denominator without any change, 2, but the numerator we get that 2 times 4 plus 1. 2 times 4 equal 8. 8 plus 1 equal 9. Okay, next B, 0.4. 0.4 is a decimal number. I need to change it to a fraction. Okay, 4. I know that when we have 4 in 10th place, 10th place, that we need that to put it 4 over 10. Why 10? Because 4 in the 10th place. 10th place, 4 over 10 equals 0.4. See, negative 5. Negative 5, it's already an integer, right? Any integer, I can write it negative out of the fraction and 5 over 1. Any number without a denominator, I can put 1 in its denominator. Okay, negative 5 over 1. 1.2. 1 is a whole number, and 0.2, 2 in the 10th place. 10th place, put 10 denominator. Okay, now I got mixed number. I learned before to convert mixed number to a fraction by putting the same denominator and get the numerator by multiplying denominator times the whole number plus numerator. 10 times 1 equal 10 plus 2 equal 12. Okay. Question number 2. It shows the best subset of the following for each number. Note that he asked us about the best subset. What he mean about the best subset? Let's see. Point A, 0 is space number. Is 0 is a rational number? Yes. Integer? Yes. Counting? No. 0 is not a counting number, but it is a natural. Which set I choose? Rational or counting or natural? Look at the smallest set. 0 is a rational and integer and natural, but the best subset is natural. Okay, negative 2 over 3 is space number. Negative 2 over 3. Of course, negative, it's not natural, it's not counting, but it's integer and already it's a rational. Okay, but the smallest is the integer. So integer is the best subset. Integer. We know that it's wrong. Why? Because integer is not a fraction. Integer is not a fraction. So we have to have rational number. Okay. Negative 4. Negative 4 is not natural or counting. It's integer. for the best subset. 5. Oh, 5 is a rational, integer, counting, natural. It's all is true. But which one is the best? The smallest one, 5, belong to, as an element, belong to counting number. Okay. Question number 3, write belong or doesn't belong. We learned before that belong and doesn't belong between element and set, right? Okay. The element here 2 over 1 blank to set of rational number. Is 2 over 1 is belong or not belong? Of course, 2 over 1 as a fraction a over b belongs to set of rational number, so write belongs. Negative 3 over 4 to set of integer. Note, it's a fraction. It's a fraction. Of course, it's a negative, but it's a fraction. Integer doesn't have any fractions. Okay? So, it's not doesn't belong to. Question number 4. Write a subset or not subset. Subset and not subset between two sets. Between two sets. Set of counting and set of integer. Yes, counting, subset of integer, because counting is a small one and integer is the big one. So, it's a subset. Okay. Rational number and natural number. Is a rational number the biggest group? Is a part of natural number? Of course not. So, of course, rational number is not a subset of natural number, and it's end of the check. Okay. Learn number 2. Representing the rational number on the number line. Now we know that rational number contain counting number and natural number and integer. All these sets are rational number. Okay. To represent rational number on the number line, this line, okay, we have three start. Okay, 3 points to start with. Number 1, to put 0. Just draw the line and put 0 in the middle of this line. Next, we have a positive part on the right or to the right of 0, and we have negative number to the left of 0. Positive to right of 0, negative to left of 0. And we will learn more in our next example. Example number 6 represents the rational number 3 over 4 on the number line. I want to represent this rational number 3 over 4. Of course, 3 over 4 is not a counting, is not a natural, is not an integer number. It's just rational number because it's a fraction. How to represent this fraction on the number line? Note that just start with drawing a line. Okay, it's easy. We said that we have two points to start with. Point 0. Put 0. Where is 0? Here. Okay. Next, we have positive here and negative here. Okay. First, 3 over 4 is positive or negative? It's positive. So it will be on the right, to the right of 0. It will be here, to the right of 0. Because it's positive, it's not negative. Okay. Next, What about 3 over 4? 3 over 4, I need to know this number line. We use to put 1, 2, 3, 4, 5, 6 or integer. Now we have to know 3 over 4 is laying between two integer. What's the previous and the next integer? Okay. 3 over 4 is a fraction, right? It's a fraction. We know that fraction is in between 0 and 1. Any fraction lying between 0 and 1. It's bigger than 0, okay, and less than 1. Note that it's improper fraction. It's improper fraction. Okay, so it's not a mixed number. Note that. Okay, now I know that 3 over 4 is lying between 0 and 1. So I have to represent 0, okay, and 1. Where is 1? Let's put 1 like here. Maybe put 2 and 3, or maybe put -1 here, okay, but I need the distance between 0 and 1 because it's the distance, it's the point of 3 over 4. Okay, what's next? Okay, next I know that 3 over 4 between 0 and 1 because it's a fraction. It's improper fraction. Now, where is here? Exact. Okay, look at the denominator. 4. Yes. So I will divide this distance about to 4 part. Here put the first point here. Just we have 2 part. Every part divide it 2 part. Oh, now we have 1 part, 2 part, 3 part, 4 part. Okay, this is 4 part. Now look at the numerator. We have 3. Count 3 from the 0 in the direction to 1. 1, 2, 3. Here put 3 over 4. What's here? 1 over 4, just 1 part. Here 2 over 4, 2 part. 3 over 4. Here we have 4 over 4. 4 over 4 equal 1. Here we have 0 over 4. 0 part. I have no part. Okay. Here we have 4 part. 4 over 4 and 0 over 4. 0 over 4 equals 0. 4 over 4 equal 1. Here we have 1 part, 2 part, 3 part over 4. Now this is the representing of rational number 3 over 4 on the number line. Remark. Rational number A and negative A. A and negative A, we know that it's as the opposite of each other or the additive inverse of each other. Okay, like 5 and -5. It's opposite each other. Okay, I need to represent two numbers like that, like 3 over 4 and -3 over 4. We learned before to represent 3 over 4. Here have 0. Okay, then I know that it's improper fraction, so it's between 0 and 1. 0 and 1. Okay, we have 4. We have 4 part. 1, 2, 3, 4. Okay, I will count 3 part. 1 part, 2 part, 3 parts. So we put 3 over 4 here. Where I can represent -3 over 4. -3 over 4, it's easy. It's the same way, but in the other direction because it's negative. We said that here we have positive and here we have negative. Positive, we put 3 over 4 here, but if it's -3 over 4, the same steps, but in the left direction of 0. So we have 1 part, 2 part, 3 part, but 3 over 4 by the negative sign. Okay, we have here 3 part positive direction, and we have here 3 part is a negative direction. Example number 7. Graph each rational number on the same number line. He wants us to represent all these rational number on the same number line. Let's see how we solve this problem. First, we draw the number line. Okay, maybe use a line. Okay, we use the line. Okay, now we have to put 0, like here, 0. Nice. Next, look at the first one, 1.5. First 1.5, I have just one integer, okay, and 0.5, one integer, I know it. Where is 1? Let's put 1 here. Okay, 1, but I need 0.5. 0.5 equal what? 0.5, here we have to change the decimal number to a mixed number. So 1 and 5 over 10, right? 5 over 10, if we may simplifying it, dividing by 5 equal 1, dividing by 5 equal 2, and the one integer here. Now it's clear. I have 1.5. Okay, I have 1. Where is the half? More half. Then I will move to right in the positive direction to find the half. This half may be 1.5 is between 1 and 2. It's in between 1 and 2. Okay, here we have 1, but here 2. Okay, now I know that 1.5 or 1.5 located between 1 and 2. Okay, where it's exact it's located? I have 2 parts by 2 in denominator. Okay, 2 part. Okay, and I need just 1 part. Start from the smallest integer 1 and go to right. Okay, and just count 1 part. 1 part here we have 1.5. Okay. Okay. Next, half. Half is an improper fraction. Or proper fraction? No, it's a proper fraction. Proper fraction in between 0 and 1, direct. 0 and 1. Okay. Okay. How many parts? 2 parts. Divide it 2 parts and count 1 part from the smallest 0 to 1. 0, 1 part. Reach here we have half. Okay. Okay. 2 over 8. 2 over 8, it's proper fraction, but it's not in its simplifying or the simplest form. We have to simplest it. 2 over 8 over 2 equal 1 over 2 equal 4. It's quarter, right? It's proper fraction, it's in between 0 and 1. 0 and 1 and divided it to 4 parts. Here we have 0 and 1, but 2 part, divided it to 8 part, to 4 parts, sorry. Here we have 1, 2, 3, 4 part. I need to count just 1 part. Start from the small, 0 or 1, I start with 0 and count 1 part. From 0 and count 1 part, we reach here. Here we have quarter or 2 over 8. It's the same, quarter or 2 over 8. Next, negative 2 and 2.5. Note that it's negative, so it's here. Okay, to the left of 0. It's the first point. Number 2, 2.5. 2.5, it's equal 2 and 5 over 10. Equal 2 and over 5 equal 1 over 5 equal 2. It's 2 and half. Yeah, in the negative direction. 2 and half. 2 and half. It's between 2 and 3. 2 and half. Between 2 and 3. But note that it's negative. Don't forget it's negative. It's negative. Okay. So I need to put or represent negative 2 and negative 3. Here we have 0, negative 1, negative 2, negative 3. Okay. Okay. First we have negative 2 and negative 3. I have negative 2. Okay, I have negative 2 and half. Now let's see where to start, with negative 2 or with negative 3. We said that we start with the closest to 0. Here we would start with negative 2 and move to negative 3. Okay, negative 2 and move to negative 3. Okay, I have a fraction 1 over 2. We have two parts. Okay, and just count one part from the smallest one, negative 2. One part here we have negative 2 and half or negative 2.5. Okay, last one, negative 3 and quarter.